We're going to factor by the method of the difference of two squares. Now notice what it's called. The difference. Difference is subtraction. So that means there's going to be a subtraction sign between them. Two squares. That means that both terms will be a perfect square. X squared minus 36. This is my first problem right here. X squared minus 36. X squared is x times x. It's a perfect square. And 36 is 6 times 6. It's a perfect square. So this is the method. This is the rule. A plus b times a minus b. If you were to multiply those, you get a squared. Negative ab. Positive ab. Negative b squared. Notice that the two middle terms cancel out and it's a squared minus b squared. They will always be, you'll recognize this, there will always be only two terms and there will always be a minus sign between them. Both of these will be perfect squares. When that happens, all you have to do is square root the first term, and if I square root x squared, that gives me x, and square root the last term. The square root of 36 is 6, and then you literally just put a plus sign and a minus sign between them, looking at the rule. So my answer for the first one is x plus 6, x minus 6. Now, you will always have two terms. Notice how I've noted this here. The difference of two squares will always have two terms, and it will never have a middle term, never. And the last term will always be negative. There will always be a minus sign, always. Never a plus sign between two perfect squares. All right, so remember, this procedure, this process, this one is so easy that when you practice it the first day, you'll fly through it, but it will be the one later on when we're doing rational expressions that you will be most likely to forget because you did not have to work hard for the knowledge. So, anyway, if I square root a squared, I write a. If I square root 81, I write 9. And I write a plus 9, a minus 9. Now, the plus sign doesn't have to go first. You could write this, a minus 9, a plus 9. But you need to have both a plus and a minus sign, and it doesn't matter the order you put them in. All right, let's go down here. We have 4x squared minus 25. 4 is a perfect square, 2 times 2. 5 is a perfect square, 5 times 5. Square root them, 2x, 2x, square root, 5, 5, plus minus, 4 minus plus. Come down, do the same thing here. 25, square root of 25 is 5. Square root of 121 is 11. Write them down, plus minus. Now, this problem is here simply because it has a GCF. You'll look at it and you'll think, okay, that's not a perfect square. 3 and 75. No, they're not. But 3 does divide evenly into both terms. So you pull 3 out, and now you have the difference of two squares. So the square root of x is x. The square root of 25 is 5. And you write your plus and your minus sign, and you go on. This one has a plus sign between it. Be very, very careful. Both those terms are perfect squares, but this is not factorable because I have a plus sign. I have to have a minus sign. So I cannot factor a sum of squares, but I can factor the difference of squares. So prime or not factorable. Thank you.